So energy is the core driver of metabolic function. If energetic needs are being served, it's most likely the protein's going to tag along with it, all right? So when we get into very high production feeding systems, that's a different story, okay? And again, if we're talking about concentrate supplementation of low quality roughages or standing low quality feed, okay, which we're likely to have in the middle of winter here, yeah, the protein story becomes a little bit more important, and having a good source in that situation of digestible protein, both some bypass protein but some non-protein nitrogen sources, can greatly assist in the digestibility of standing roughages. So if your goal is production feeding, supplementary feeding of low quality forages, yeah, the protein story becomes important. Macro minerals, look, true deficiencies are rare, but these are probably the two big ones, okay? And making sure we're dealing with calcium and phosphorus in our ration formulation when we're on hay-based diets is particularly important. And calcium is probably the one we run short of first, okay? But phosphorus can be problematic as well, depending on the type of hay and where the hay has come from. Summer grass type hays tend to be very low in both. Cereal hays tend to be low in calcium in particular, okay? We've had some really interesting deficiency syndromes. There's one that we worked up with here that they'd been feeding rodeo bulls, okay, with summer grass hay and bread meal. So energetically it was okay, but neither of those had any calcium in them, right? And what we ended up happening is rodeo bulls were broken hips, all right, because the bones were just breaking down. So, you know, the calcium becomes a really important story, particularly if you're on very acidic country or country that's got high aluminium levels in the soil, and that will be a number of the people in this room. All right, so in those situations, if you haven't had a strong liming history, you know, calcium is something we do need to think about. Macro minerals and vitamins, yep, important, particularly as it gets dry, okay? A couple of our key vitamins, such as vitamin A, vitamin D and vitamin E, they're quite high in green feed, okay? But once that green feed disappears and we've been on dry standing feed for quite a while, or dry supplementary feed, some of those fat-soluble vitamins do become important. And one that we see quite often is probably the vitamin A. Okay, vitamin A can be problematic, highly related to immunity, particularly related to immunity in the eye. So one of the things that we see when we've got drought, you know, is a lot of pink eye. Okay, and some of that can also, not only is it because of the prevalence of the bug and lots of flies and dust, because there's a lot of vitamin A in the system, the immunity or the immune function of the eye deteriorates, and that's why we can be more exposed to pink eye during dry times as well. So look, where does energy come from in feed? And the great thing about ruminants, okay, is that ruminants have got this ability to digest a fair amount of the fraction of fibre. So with the energy itself, it's actually derived, if we think about all these plants as sort of cells, which is what they are, because most of our food sources are derived from plants or plant cells. Most of the good stuff is actually contained within the juice of the cell. Okay, so this is sugars, starches, if it's grains, a lot of our proteins. Okay, and this is the highly digestible fraction of feed. Now, the younger and the fresher and the more vegetative the feed is, the higher the proportion of that feed sits within the cell wall. Okay, as the plants mature, okay, what the plants need to do as they mature is that they need to get tall. For plants, they need to get tall so they can throw up a seed head, okay? And throw up a seed head to get pollinated and to go through the next generation. So part of that is that the plant needs to become stronger, okay? So to become stronger, it needs to become more fibrous, okay? So as the plant matures, the juiciness of the plant starts to convert into a more fibrous plant, all right? So as that plant becomes more fibrous, the proportion of the stuff inside the cell decreases, and the proportion of stuff that makes up the cell that gives it its strength, the fibre, increases. All right? And this is the classic decline in feed quality we see as feed goes from this high to this high. All right? More feed, but a rapid decrease in the quality of that feed and the energy density of that feed. So we can have vast amounts of feed that's even this high, all right? But the quality of that feed and the ability of cattle to extract nutrient out of it declines rapidly, okay? And they can do it, and that's one of the great things about being a ruminant is that they've got bacteria in their rumen, and that bacteria is very capable of breaking down a reasonable amount of the fibre. It can break down what they call the cellulose and the hemicellulose fraction of the fibre. All right, so that's just complex sugars. But then there's a third fraction in that fibre they call lignin. All right, now lignin is wood. All right, and there's only one animal on the planet that can break that down, and it's termites. Okay, so as fibre in plants gets higher, the proportion of lignin also gets higher. And what that means is more and more of that feed gets completely indigestible. One of the characteristics of the predominant grass species in this area, or types, is that they're summer subtropical annuals or perennial grasses. Okay? What we all know about those is that their cellulose and their lignin is even higher in proportion and less digestible than what we call the temperate species, so the species like cockswoods, phalaris, ryegrasses. Okay? So these subtropical species, as they mature and we develop very large biomasses of them, become even less digestible over time. So you can have this vast forest of standing wood, okay, which is very, very poorly digestible. And this is one of the challenges that we have here. Our favoured season of growth is now, okay, but unfortunately the things that are growing do not make particularly nutritious standover feed. Okay? Very, very different if we're talking about a temperate area where ryegrass might grow through the winter, or things like cockswoods or phalaris and a lot of legume growth. The standover value of those feeds is much, much higher. It's much more digestible. Okay? And that's okay. That's just how it is. We just need to work out what to do about it. Okay? Does that make sense? Yeah. So look, the amount of energy in the feed. Have everyone heard about how we talk about energy? We talk about ME, or megajoules of energy. Basically, it's a measure of the density of energy within a feed. So we talk about megajoules of energy, the amount of energy per kilogram of feed. We also talk about it in terms of kilograms of dry matter. Okay? Now, dry matter is a really, really important concept to fully understand, particularly when you start buying feed. Okay? Now, when we talk about a feed, the way that we can equilibrate them is by basically removing the water. Because we can have 100 kilograms of grass, okay? It might be 15% dry matter. So the reality is there's only 15 kilograms of true feed within that 100 kilograms of grass. We can talk about 100 kilograms of wheat, okay? It's 90% dry matter, okay? The reality is in that 100 kilograms of wheat, all right, there's 90 kilograms of feed. Does that make sense? All right. So one of the big traps that we see is when people just go and buy feed per tonne, okay, without actually understanding what the value is per tonne of dry matter. And I'll talk you through a few examples of this a little bit further in the presentation, where people get absolutely smacked on buying feed per tonne, particularly buying wet feeds and particularly buying silages, okay, because silage could be up to 60% water. Okay, so a tonne of silage is a very, very different thing to a tonne of hay. They're completely different feeds. But a tonne of dry matter, okay, if we take the water out and we equalise things, that makes a lot of sense, all right? Because then we're actually looking at the true feed once we take the water out. The amount of feed then is expressed basically as ME, and we talk about it in megajoules, okay, which is, you know, 1 million joules, all right? And basically we can then start thinking, well, this feed is 10 megajoules per kilogram of dry matter. This feed is 8 megajoules per kilogram of dry matter, all right? The 10 megajoule has got a higher energy density. There's more energy per mouthful, okay? And there's some really good things about that, okay? Because we know that the higher the energy of the feed, the less of it you need to do the job that you need to do. Or the flip side of that, the more of that you can get into it, the more growth you're actually going to get compared to feeding the other animal. So we express it in terms of megajoules of ME per kilogram of dry matter. Dry matter is the amount of true feed left after we squeeze the water out, all right? So we should always be talking about feed, right? Not per bale, not per kilogram, but per kilogram of dry matter, all right? Because that gives us an equaliser. Sources of energy, carbohydrates. So we talk about non-structural carbohydrates, sugars, starches, fructans, which are a type of sugar. Okay, this is the stuff that's readily available within the cell to break down quickly for the ruminant. We talk about structural fibres, pectin, cellulose, hemicellulose, lignin, and this lignin fraction, we can't digest it at all, okay? Mostly used by rumen microbes as an energy source the bugs sit there in the rumen, they take in this energy, all right, effectively they use it and they fart it back out the other end, and they produce what we call volatile fatty acids. The volatile fatty acids, which is effectively the refuse of rumen utilising sugars and fibre, that's absorbed by the ruminant. It goes through the rumen wall, gets moved through to the liver, and the liver does really cool stuff with it. It either turns it into fat or glucose, okay, and that turns it into the energy source for the cow. So at the same time, while we're feeding these bugs and they're multiplying, okay, they're reprocessing these forms of energy into a form that the cow can then use. At the same time, they're also growing more bugs. And by growing more bugs, which is what we want to have happen in a rumen, okay, we double the number of bugs. Those bugs suddenly start getting passed through into the lower parts of the digestive system of the cow. They get broken down and they effectively become protein for the animal, all right? So all this stuff about ruminants, it's not just about feeding protein, it's about feeding some protein, but it's also about feeding bugs. And if we feed bugs and we get more bugs, the bugs have this wonderful habit of releasing these products that the ruminant absorbs, turns into sugar and fat, okay? But then by doubling the amount of bugs and they go into the intestine, they're effectively providing protein and further food for the cow that it turns into protein itself. That's just a very quick trip through ruminant digestion, all right? There's a little bit more to it than that, but that's, if you get it that we're growing bugs, okay, and that the energy is about feeding the bugs, and then the bugs reprocess the energy and we can reuse that, and we grow more bugs, and that gives us more protein, happy days.